Okay. The next thing we're going to be talking. Sorry, we're going to be talking about integration by parts. It's another integration techniques. Integration by parts. What you're going to see is this is the basic example. The integral of x e to the x dx. Now. Yeah, so you're looking at this, and what's going on? What do you see? You see the product of two functions. So generally, it's the product. And the idea is this. Maybe this has some connection to the product rule. Now, let's think about this. So, what you're going to do is here's the theory behind it. Let's call two functions u and v, right? And so u is one function, v is another function. We're going to take the derivative of u and v. And so we know it's u prime v plus u v prime. So it's, if you have the derivative of two functions, derivative of the first, keep the second, plus the derivative of keep the first, derivative of the second. Okay, then the next thing they do when they derive the formula is they take the integral of both sides. And so we have, what's the integral of the derivative? It's uv is equal to the integral of u prime v plus the integral of u v prime. And that's where this comes from. So the idea is they move this to the other side. And so we have the integral of u times v prime is equal to uv minus the integral of u prime v. And so I cite, remember it, yeah. So, how are we going to use this formula? Very easy. So you're going to look at this, and you're going to let u equal x, and the derivative, dv, be the second function. Okay, I'm going to tell you how you know which one is which in a bit. Underneath it, you're going to write du, or u prime. So it's written like this. So it's u dv equals uv minus v du. This is how you're going to see it, but this is the idea. It's the same thing. U is x, and the derivative is e to the x. The du is 1, and the integral of dv is e to the x. And so the integral of x e to the x is equal to uv minus the integral of v du. Final answer, x e to the x minus e to the x plus c. Let's try another one. X sine x. There's not that many of these, and they'll say integration by parts. It's a technique. Same idea here. So the question is, how do you know what's the u and what's the dv? Let's just try another one like this. So once again, let x be u, and let dv equals sine of x. The du equals 1, v equals negative cosine of x. You can see the board. And then we say uv minus the integral of v du. uv minus the integral of v du. So this is equal to x negative x cosine x minus the integral of negative cosine x dx. Well, this is plus, final answer, negative x cosine x plus sine of x plus c. How do you know what's the u? Liate. Whatever comes first, that's the u. So if the first term is a logarithm, that's the u. if the first thing you see is, if you're, so I don't see a logarithm, I don't see a logarithm. The next thing you look for is inverse function. Next thing you look for, algebraic. Algebraic. Oh, x. Oh, x. That's the u. The next thing, trig. So, no. And then the next thing is exponent. Exponent. Good. How about we try this one? What is the integral of x ln of x dx? So you might think, So you might think that the u is the x. You might say, oh, u is x, but no, because what logarithm, the ln is the u. So we take it off to the side. I mean, you could try it, and you run into like circles. You might, so this, u is x. And dv is ln of x. Well, we don't know what the integral of ln. I think the integral of ln of x, that's what? That's like x ln of x minus x, so that doesn't work. But we know the derivative of ln of x is 1 over x. That's why it's first. So you're like, okay, I have a logarithm here. That's my u, and therefore my v is x. And so du is 1 over x, and I'm sorry, this is dv. V is, x squared over 2. And so this equal, once again, it's the integral, it's uv minus the integral of v du. So it's equal to x squared over 2 ln of x minus the integral of 1/2 x, right? Because it's x squared, so it's a 1 over x times x squared over 2 dx. Final answer, x squared over 2 ln of x minus 1/2 ln of x plus c. No, that's wrong. That's wrong. I apologize. It's the integral of x over 2 dx. Final answer, x over 2 ln of x minus x squared over 4 plus c. Yes. Okay. The next part, okay, how about this one? The next thing they're asking you to do is, and I'm just going to show you just little tricks of the trade. The integral of ln of x dx. How can we integration by parts? Well, if we have a secant 1 in there, then we let u equal ln of x and dv equal 1, then du equals 1 over x. Yeah, and u equals x, it works out nicely. And so this is equal to x ln of x minus the integral of 1 dx, which is x ln of x minus x plus c. You can also do it with the arcsines and the arccosines. The integral of like, I think they wanted the arctangent of theta of x dx, the same idea here. U equals arctan and dv equals 1. We know what the arctan is, the derivative of arctan. It's, what is it? It's 1 over x. I believe it's 1 over x squared. Yeah. So you can figure that out. The derivative of arctan is, I believe it's 1 over 1 plus x squared, and the integral, that would be x. And so you have this is equal to x arctan of x minus the integral of x over 1 plus x squared dx. And this works nicely. This is a substitution problem. Figure this out. I think that's right. Yeah. And then just practice these extras. The last thing we want to do is something called when an integration of a part repeats over and over again. And it's very basic. They're gonna say like do it twice. This shows up when we have this example, the integral of e to the x sine of x. And you think it's 2x, and you're like, okay, I can do this. I know the rules. And it's clearly integration by parts. And I know that e to the x is the u, and dv is the sine. And you go through the motions. Du equals e to the x, and v equals negative cosine of x. You go through it. You say, okay, it's uv minus the integral of v du. So you're like, okay, this is equal to e to the x, negative e to the x cosine of x minus the integral of, negative e to the x cosine of x. And this come up, and you're like, wait a minute, like, I'm stuck. In this case, do it again. Do it again. So you're like, okay, mister, I'll do it again. Fine. The integral of e to the x cosine of x dx, I'm going to let my u be e to the x, and let my dv equal cosine of x. You're like, fine. Okay, du equals e to the x, and v equals sine of x. And you say, fine. So I have e to the x sine of x minus the integral of e to the x sine of x dx. And you're like, well, I'm going in circles. Exactly, you're going in circles. Because, and this is where you stop. You're done. You're done. Because if we let, so now we have the integral of e to the x sine of x is equal to negative e to the x cosine of x plus e to the x sine of x minus the integral of e to the x sine of x. But here's the trick. Ready? We're going to let this equal a. We're going to let that part equal a. That means we have here a equals blah, 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 blah minus a. Therefore, we have 2a equals negative e to the x cosine of x plus e to the x sine of x. And therefore, to conclude, a, which was our original integral, is equal to 1/2. I'm going to fix this up to make it nice and pretty. E to the x sine of x minus e to the x cosine of x. You're going to try that? Yeah. And so, but they'll tell you. So, that's it. And we're done with chapter 19.